In this lecture, we are going to discuss about EMF or voltage commutation method to improve the commutation in DC generators. Already we discussed first method to improve the commutation in DC generator, that is resistance commutation method, in the last video. So here we will see the EMF or voltage commutation methods. We know that the coil under commutation will induce a voltage in that coil due to the flow of current through the coil, and that voltage is self-induced EMF. That self-induced EMF is also known as a reactance voltage. Reactance voltage is nothing but it is the voltage induced in the coil under short circuit period or during the commutation period. That is one of the major important reason for poor commutation in DC generator. So we need to neutralize this effect of reactance voltage. For that we can adapt one method, that is voltage commutation method. This method includes two things. We can neutralize the reactance voltage by brush shifting method, and the second one is by using interpols. We can discuss about the first method here, that is brush shifting method. We know that brushes are always connected in magnetic neutral axis. At no load condition, this magnetic neutral axis and GNA geometrical neutral axis will be in the same line. Whenever the machine get loaded, armature current will start flowing through this, and the position of magnetic neutral axis or MNA will get shifted as the same direction as that of the direction of rotation of the armature conductor. If it is using as a generator, then movements will be like this direction. If it is using as a motor, then the position of MNA will be shifted to this position. So here it is using as a generator. So the armature is rotating like this. The position of MNA will be just shifted to this direction along with the brush. The position of this MNA will change when during changing load times from no load to full load. If the load is changing, then the position of the MNA will also change along with this brush. Due to these reasons, they are not practical in use. This brush shifting methods are very limited in use. Mainly due to two reasons. First one is MNA changes with the changing load conditions. Okay, from no load to full load, based on the armature current and based on the armature reaction. Okay, so based on the rotation of this armature, the position of MNA will also changes. The second point is direction of MNA is shifted depends on the mode in which the machine is operating. If it is using as a motor, then the position of MNA will changes in this direction as that of armature or direction of armature. If it is using as a motor, then it will rotate in the reverse direction. So the position of MNA will be needed to change if it is using as a motor and as well as a generator. So that will be, these are the two difficulties in order to use brush shifting method for better commutation. So they are not in practical use. So we are using the second method, that is use of interpols or compols. Compol is the another name for interpols. As the name indicates, interpols, they are always connected in between the main poles. From this name we can clarify that. So here you can see a two-pole machine, and if there are n number of poles, then there will be n number of interpols. So the number of interpols will be always means it is normally equal to that of main poles. They are always connected in between the main poles. And the important points about the interpoles are they are fixed to the yoke like main poles, and the polarity of the interpole will be same as that of the polarity of main poles, and they are connected in series with the armature. You can see that this is the armature, and through the brushes they are connected directly connected to the interpoles. So interpoles and armature windings are always connected in series. These interpoles are able to carry the full load armature currents, and the interpoles provide more mmf, magnetomotive force, than that of armature. So we will discuss about the reason for that. And before going to discuss that, we must ensure that the EMF induced in these interpoles must be always equal and opposite to that of the reactance voltage. Then only the reactance voltage will get neutralized. So equal and opposite. Then we can say that the EMF induced in the interpole will be reversing EMF or commutating EMF. We can say that the EMF induced in the coil is reversing or commutating EMF. Based on these concepts, we can say that function of interpoles can be two. First one, they will make commutation sparkless by providing equal and opposite EMF, that is reversing EMF or commutating EMF, and this EMF will neutralizes the EMF induced in the short circuited coil, that is reactance voltage. So the reactance voltage is the main reason for sparking. So that reason is completely neutralized by the interpoles by producing reversing EMF in it. And we know that the second point, this neutralizes the cross magnetizing effect of armature reaction. Already we discussed about the armature reaction in the previous videos. And the use of interpoles will neutralizes this cross magnetizing effect. We know that the interpoles will provide more mmf than that of armature mmf. Almost it is 1.2 to 1.3 times higher than that of the armature mmf. So this mmf will opposes the cross magnetizing effect. Hence we can use these interpoles to reduce the armature reaction also. So these are the major points about interpoles. They are mainly used to reduce sparking, and thereby they will provide a better commutation, and armature reaction, effect of armature reaction can also reduce. Major purpose is to provide sparkless commutation. Okay. So these are the major points about the EMF or voltage commutation model. In the next video, we will see how compensating winding reduces poor commutation in DC machines. Okay, thank you.